Hi, good afternoon, everyone. Welcome to Lombardi for, I think, the final talk of the day here. Sean is going to be talking about declarative configuration management in Lisp. It is going to be a pre-recorded talk in the video and then a live Q&A afterwards. So thank you and enjoy the talk.
Hello everyone, I'm Sean Whitton and welcome to my talk on Consfigurator, the Lisp declarative configuration management system that I've been working on for about a year and a half. Let me just take a moment to thank the content team and the video team for allowing me to do this talk pre-recorded. When I had to cancel my DebConf registration, very sad, I thought that I would just have to cancel this talk as well. They said that I could do it pre-recorded, and it's great not to have to cancel the talk, so thank you very much. Alright, by way of introduction, many of you are probably familiar with Propeller, which is another configuration management system written in a language that not so many people use. It's written in Haskell by Jerry Hess, a former Debian developer. And Propeller was presented at DebConfs 14 and 17. Now I was a user of Propeller from about 2015 until 2021, and Consfigurator is in a lot of ways a rewrite of Propeller in Common Lisp. And so by way of introduction, I just wanted to say why I wanted to try to improve upon Propeller. So there are two key ideas, I think, with Propeller. The first one is to try and make use of Haskell's type system to find configuration problems before it goes near any hosts. And the other key idea with Propeller is that your configuration of your hosts is expressed in Haskell 2. There's no YAML or JSON. Using the type system to detect system administration problems early is very cool, but it's the experience of actually doing system administration with Propeller is not like just the kind of thing you have to do in statically typed languages. Sometimes you feel like you're fighting the type checker. In Propeller it's kind of even stronger than that, because Propeller uses some of the most advanced ideas in Haskell to make it possible to check types like the OS of a host. And as a consequence, your code to perform your system administration tasks can end up quite convoluted and awkward because of the way the type system works. Secondly, a limitation of Propeller is that there's only one method to apply properties to hosts. It sends over the source code of Propeller and your configuration, and it compiles it on the remote side. And then the program that results from that is used to apply the properties, the executable. But there's some issues with this. So what about hosts where compiling a Haskell program is not really practical? So building moderately sized Haskell programs like Propeller requires large amounts of memory. You might want to configure a host which has a very low amount of memory, the low-powered ARM thing. And not only have you got the memory issue, it might just be that it compiles very slowly. A little bit about the status of the project. We've hit version 1. It's no longer experimental. The core API has been reviewed and semi-frozen. So new releases of Consfigurator are not likely to break your code, your configuration. So it's definitely suitable for production systems. In fact, it's being used on a number of production systems. And as far as portability is concerned, it currently runs well on Debian using the SBCL implementation of Common Lisp. So Common Lisp is an ISO standard, and there's multiple implementations. SBCL is the most prominent free software implementation, and Consfigurator is mostly developed, well, entirely developed, in fact, on SBCL on Debian because that's what I use. But portability is something that I've had in mind, and there's no reason to think that it wouldn't be portable to other Unisys and Common Lisp implementations. It's mostly a matter of if-defing out the Linux and SBCL specific features. So let me just introduce the basic architecture, the components that you put together to perform your system administrative tasks. Here they are. So a property, this is terminology that I'm just carrying over from Propeller, is a piece of configuration, something that can be true of a host or that can need to be made true by the configuration management system. And a host is a list of properties, the properties it's meant to have when it's fully configured. And it's also associated with a list of host attributes. So the Propeller name for that is info, that's the type. And that's things like a host name, that would be a host attribute. So then a connection is a means of applying properties to a host. So the most basic connection type, I suppose, would be the SSH connection type, which applies properties by running shell commands using SSH. And then a deployment is when you put these together. So you put together a host, which is made up of properties, and you put it with a connection, or more than one connection. See some examples of that. And that gives you a deployment. All right. So those are the most basic components. And then finally, prerequisite data just means anything you need to apply a property that can't just be embedded in that property's code. So secrets are the most obvious example of this. If you've got some property that sets up an SSH daemon and installs private keys for it, then the text of the private key, you don't just want that to be a string literal in your code, right? You want it to be in some kind of secret storage mechanism. And so prerequisite data is how Consfigurator handles such things. Okay, so then how do you put these together? Well, Consfigurator, when you install it, is sort of inert. It's just a library, no different from a Python library or a Perl library that you might have installed on your system. It just becomes available for being imported into your own code. And your configuration of your hosts in the standard way to use Consfigurator is just another Lisp library. And I call this your config. So the user's configuration of their hosts is just another Lisp library. So you've got these two Lisp libraries. And basically, what you do is you load them into Lisp, you import them as libraries, and by doing so, libraries provide functions and types, classes, and that's what happens here. So when you import Consfigurator in your config, then your hosts will be defined by your config, and properties will be defined perhaps by both of them, and you'll get your what I call data sources, means of obtaining prerequisite data. And then what about deployments? Well, you typically construct your deployments on the fly at the REPL. So properties, hosts, and connections are just code, and deployments are sort of like commands executed at the REPL. Now, you can, of course, execute deployments programmatically. You don't have to do it at the REPL, but this usage pattern turns out to be pretty nice for system administration tasks, and hopefully you'll see what I mean with the demos. Speaking of which, let's do the first demo. So I'm gonna do this in Emacs, but I wanted to mention that Emacs is not essential. You can run your Lisp REPL in a terminal emulator just as well, or I suppose an IDE perhaps, I don't know. I'm going to run it in Emacs, but yeah, I'm not going to use any fancy Emacs stuff. So what we do is we just run this thing slime, which is the superior Lisp interaction mode for Emacs. It's just the thing that handles the REPL, and it will start up SBCL for us. And then, as I mentioned, what we want to do is load up, we want to import, as you might say in another language, Consfigurator and my config, in which I've defined some demos. And to do that, this is how you do it. All we actually have to do is load the config system, because my config expresses a dependency upon Consfigurator, right? So this will load up the core library as well. So just load that, and there we go. And then we can get going with this. So here's a definition. Here's a host definition for this laptop that I'm recording on. So it defines its host name. There's a documentation string here, and then simply followed by the list of properties. And just for this example, I've applied 2 properties to the laptop. This one, which actually just pushes some metadata. It pushes to the host attributes that it's a Debian stable machine and it's AMD64. And then this property, which says when the host is in its fully configured state, it should have this package CL5AM installed. I just picked a random package from Debian. So we've got our host, we've got the properties defined in code, and we can now construct a deployment at the REPL. So what I'll do is I'll just make sure that's loaded, and then what we do is we call this thing deploy. Let's make this a bit bigger actually. So to use deploy, you specify the connection first. I'm going to specify sudo. So sudo is, like SSH, a means of applying properties to a host, because it gets you root access to the host just like SSH can. So sudo is a connection type. We say the host, and that's that. So we can go ahead and run that, and it goes ahead and establishes a sudo connection, right? It's a real sudo connection, not a pseudo connection. And it goes ahead and applies the 2 properties that we specified, and actually it didn't do anything because, well, there's nothing to do for this, and the package is in fact already installed. But this brings up a good example of what I mean when I say it's useful to be able to apply singular properties rather than just deploying a whole host. So what we might want to do is undo the fact that this package is installed, and then run our deployment and test, therefore, that it does in fact install the package, right? So it's a very simple example, but imagine if this instead was something really complicated. So like it's this property that I've defined, my cool web service, and it does a whole bunch of things, and we want to test that if we undo some of the configuration and then reapply it, it gets everything back to the state that it's meant to be in. So what you want to do in that state is just you want to apply a bit of my cool web service without touching the definition of the host, right? So similarly here, we want to just apply a property that removes the package without changing the definition of the host, because it's meant to be installed. We just want to check that it gets installed. So we can do that. What we use is deploy these, which says don't deploy the usual properties that the host has, just deploy these ones. All right. So the connection type and the host are the same, and then I'm going to apply the property apt removed CL5AM. Okay, so I'm pretending here that the state of the host is meant to be one in which the package isn't there. So we just do that, and it will go ahead and remove the package. Okay, so 5am has been uninstalled. Do it again, nothing happens. And now we can test that our real deployment does indeed install 5 a.m. or in a more complicated case does indeed set up the web service. So we can just check. Yep, it goes ahead and installs the package, run it again, nothing happens, so we know that this is doing what it's meant to do. So that's the REPL is pretty convenient for this sort of development. In Consfigurator we have two kinds of property. We've got what are called POSIX properties and Lisp properties. So a POSIX property is one where in order to apply it, all you need to do is run some shell commands, basically. So a POSIX property just needs shell access to a host to apply itself. Or, sorry, I should say, for Consfigurator to apply the property. By contrast, a Lisp property is one that works just by executing arbitrary Lisp on the machine to be configured. So, Propeller's means of applying properties to hosts is this, basically, right? Because it compiles Propeller on the remote side, and then the Haskell code is running on the machine itself. So Consfigurator makes this available in the form of Lisp properties, but POSIX properties mean that when we can't execute arbitrary Lisp on the remote side because it's this machine with hardly any memory, say, right, then we can use POSIX properties to still perform configuration. And so the pseudo connection type that we've seen and the SSH connection type that I mentioned, these can apply only POSIX properties because what they do is they get you a shell. And these, it's not just, you don't want these POSIX properties just because for configuring hosts where you can't run Lisp. They're also useful even for hosts where you can, like this laptop, right? Because they have a much lower startup overhead. So, you know, just rerunning this deployment is very fast, right? It was only slow when it had to wait for apt to actually do some work. Whereas if we add to our connection chain a Lisp type connection, right? So the SBCL connection type starts up SBCL on the remote side, and so it can apply both POSIX and Lisp properties. If we run this, Consfigurator will have to upload Lisp code, and, well, that was actually pretty fast because there's a lot of caching going on, but it was definitely slower than that, right? Because it had to send over Lisp code and start it up. So one of the advantages of POSIX properties is that they're very fast. On the other hand, one of the advantages of Lisp properties is if the server you're controlling is very far away, then they can actually be way faster because there's far fewer round trips going on. Because with the POSIX property, you're round tripping every shell command. Whereas if you just get a remote Lisp to do all that for you, then it can gather the results and send them all at once. Now the other reason why, the real reason why we have Lisp properties and why Propeller is so cool, really, is that if you can execute arbitrary Lisp code on the remote side, you can do things that only a remote process can do, that are either awkward or very difficult, very awkward, to do just with shell commands, right? So the idea is you've got these Lisp properties when you can have them, but we can still fall back to POSIX properties when all we have is SSH access. And then you can write properties in two ways. The most basic ones are written out in terms of like basic operations like opening and writing files and calling chmod commands and stuff like that. But like the basic properties are, like, most of them are going to come with Consfigurator. You don't have to write them yourself. User properties are mostly going to be just compositions of existing properties. So let's have a look at an example with the second demo here. So what I've done here is I've defined a property, tc cronjob, and that property is just this get cloned property followed by this crontab property. And that's a new property that I can then apply to a host. And I've done it without having really to do any real coding, right, so to speak. And the result of this is that you don't need to know a whole lot of Common Lisp to make your own properties compositionally and to apply them to hosts at the REPL, which is pretty nice. So yeah, let's go ahead and just as a second demo here, let's apply this thing. So just to fill you in, the technical committee has this cron job here, and it sends out a bunch of email inviting people to nominate people to the Debian technical committee, and this is actually simplified. There's a bit more to it, but it's basically a matter of cloning this repo from Salsa and then installing this in a cron tab. And there's actually, like I said, there's a few more steps. You have to create a few directories, I think. And it's the kind of thing which it would be nice to use configuration management for so that you don't forget how it was done. And the cool thing here is, like, this cron job runs on master.debian.org under my UID, and I'm not the admin of master.debian.org, so I don't want to be asking DSA to install Lisp or, you know, a Haskell compiler in the case of Propeller, just so that I can install my cron job. What I want, really, is to make use of POSIX properties, which in fact these two are, to just use SSH to just get them applied, and we can do that. So we want to deploy these, and we can't use deploy, actually, because we don't have a def host for master.debian.org, because I'm not the admin, right? We just want to apply this property, and we need to give it a connection, and in this case we want this. We want to say SSH in as me. We still have to give it a host, master.debian.org, and then we can apply our property right here. There is a slight wrinkle here. We do actually have to tell it that master is running Debian stable. The reason for that is just that this git cloned property checks whether git is installed before it does anything, and it does that in an OS specific way, so we do have to give it that metadata. Alright, let's go ahead and run this. Okay, so it goes ahead and SSHs to master, and it takes a little time here. It does in fact complete, and since no changes were made, because once again, in fact, the cron tab is in fact already installed, and the git repo is already cloned because this thing is actually running, but Consfigurator was able to confirm for us that no further setup was required, and if, for example, we had accidentally gone onto master and deleted our cron tab, we could just run this and get it back. So that's pretty convenient. The point of this demo is that we don't have a def host, right? We're just applying a single property, but Consfigurator's flexibility with its connection types makes that easy. So these connections, we've just seen some examples of this. You can arbitrarily chain connections up to what makes sense. So here's an example of a connection chain. It says SSH, SBCL, and then this connection type, which we haven't seen yet, LXC. And what does this amount to? Well, we're saying, Consfigurator, can you please SSH to the remote host, start up Lisp, and then that Lisp image should enter an LXC that has this name, and Consfigurator will actually use the system call to do that. It'll enter the namespaces of the container. But we can flip it around. So what does this mean? Well, this says, Consfigurator, please SSH in, and then get into the LXC, and then start up Lisp inside the LXC. And of course, it can't, if it's just got SSH access, it can't use the system call, so it will use this command ns-enter to get inside the LXC, and then start up Lisp in the way that we've already seen. And so, like, these different chains are suitable for different cases. So suppose that the LXC is running on a machine where we don't want to install Lisp on the hypervisor for whatever reason. Well, we can do this, right? And just install Lisp inside the LXC and still use Lisp type properties, and we don't have to install Lisp on the hypervisor, so pretty convenient. But if we can install Lisp on the hypervisor, then doing this is gonna be faster if we've got a whole bunch of LXCs, right? Because this Lisp image that gets started up to this point, you wouldn't express it quite like this, but it's equivalent. You can have it fork and enter each of the LXCs in turn using system calls, and that's going to be way faster than copying all the Lisp code into each LXC and starting it up. So the flexibility from arbitrarily chaining these connection types can solve a lot of problems, and I'll do some more examples of those. But a few more examples on the slide first. Here's a case where we've said, okay, SSH in as root, all right? Start up Lisp, and then set UID to another user. So, just like the case where you've got a whole bunch of LXCs, this is pretty convenient if you need to do things as several users. And you can always do everything as root and then after the fact change all the ownership and permissions, but that can be awkward. It generates code that's hard to read and relatively brittle. So you can just add an element to your connection chain to set UID and apply the configuration as the user that it actually needs to be as. And in all these cases, the entering an LXC and set UIDing are ways of giving up privilege, basically, and everything is set up such that the process with fewer rights doesn't have access to any secrets or other prerequisite data that the process running as root might have. So once again, we've got a definition for my laptop, and I've applied this property here, which says what we have here is an inline definition. That's not quite what I wanted, that's what I meant. This is an inline definition of a host, right? A host that's running Debian Unstable and has systemd installed. And this root property says, okay, build a root file system for this host implicitly defined, and put it there. So you can, you don't have to define it inline. You can do this. So just pick another machine. There we say, okay, build at this location a root file system for this host, where this thing is def hosted. But you don't really want a def host just for a chroot, a generic Debian Unstable chroot, right? So you can express it like this. Now, I've already built this chroot, because that's not the quickest thing. It has to be debootstrapped. And let me show you an example of how Consfigurator can help with one's usage of that chroot. So let's just get a root shell here. And one of the things you can do with root file systems like that one is set up volatile containers. So I don't know how many of you use this. I mean, I don't myself. But there's this thing, systemd nspawn, and what you can do, just remembering the parameters here, or reading them off my notes, what you can do is you can say, okay, can you please boot an ephemeral container based on that chroot? Okay, so we can run this, and we get a Debian Unstable system that's really just ephemeral container, and once we kill it, it's gone completely. Any changes we made are discarded. So, this is pretty convenient for testing. So, you've got this thing, and this is an ephemeral container, so you're not going to have a def host, right? This is the only configuration that's actually going to be recorded. We're not going to record anything else. But you might be in a situation like this where you would really like to apply some of your configuration to this temporary container because you want to test it, right? And then just as a more mundane example, right now we can't actually log in because root doesn't have a password. And so, we could just kill this, enter the chroot, set a password for root. But we don't really want to do that because perhaps we also want to use this chroot as a clean chroot for building with sbuild. We'd rather not touch the clean chroot, we just want to touch this ephemeral one, and Consfigurator can do that. So let me, let's say we want to deploy these, we want to apply a few properties. And here we have a somewhat complicated connection chain. So once again, we start with sudo, and we start up Lisp, and then we say, enter the systemd container with this name. Now, Consfigurator, and then we have to say that it inherits the host name, as you can see here from the laptop. Now, I wanted to note that Consfigurator doesn't actually know very much at all about systemd and spawn containers. I deliberately used something which it doesn't have good support for. Consfigurator has pretty good support for LXCs because that's what I use. But the one thing that it does know how to do, this systemd machined thing, is if you give it the name of something that appears under machinectl, then it knows how to find the root PID of the container. And then it can just apply its generic support for entering containers to allow it to enter this ephemeral container and apply some configuration. So let's see. What we'll do is we need to tell it once again what kind of system it is. It's Debian unstable. And then, well, how about let's say that we want to test the TC cron job property that we were just playing around with. So we want to apply this TC cron job thing to this ephemeral container so that we can check that it does the right thing. Slight wrinkle here, we have to install cron because otherwise that property will fail, but that's sort of irrelevant detail. Okay, so let's go ahead and apply that. Alright, and it's done. So we can see, let's have a look at the output here. So we established a pseudo connection, we started up a remote Lisp, we reassociated to the namespaces of the root process, and then we went ahead and installed cron and cloned the repository from Salsa, and populated the cron tab. And I forgot about the root password thing, didn't I? So let's just, there's this property which is really only for testing, which allows you to which allows you to set passwords. So we just set it to passwords, just apply that. And there we go, and now we should be able to log in. Oh, I typed the wrong password, hilarious. Password. And then we're in, and we can see that there's the cron tab that we requested. And we kill this container, it's gone. So what's cool about this is that we could reuse our TC cron job code and apply it to some weird pseudo host just by using the right connection chain, and therefore accomplish our goal of testing this property. And that's pretty cool. So really the final thing I wanted to say that's related to my demos is that deployments themselves are properties. Okay, so when we wrote, just go back to demo 4 here, when we wrote that we wanted this chroot to be built, we're basically turning a deployment, right, of this host into a property applied to this host. So we can do it directly. We can say we'd like to deploy the chroot directly by building a connection chain like this, sudo sbcl and then chroot into, like that, right? But we're not doing that. We're saying apply to this host this chroot as one of its properties. So a deployment is, in fact, also a property. And that means we can nest deployments, like in that example, and it turns out that this is very well suited to expressing many things, especially some distribution things, that are traditionally done without the help of declarative configuration management. So building disk images, right? So taking a host definition and building a disk image of that host instead of applying the properties to the host. And then, like, in just the same way, doing OS installation from a live system. These are stuff that Propeller knows how to do, so I wanted to mention that Consfigurator does too. As I mentioned, Propeller knows how to do these things, so I just wanted to mention that Consfigurator can too. But something new is that Consfigurator can dump executables that will execute arbitrary Lisp, and then you can have them run from cron, and this can be quite powerful. The reason that this bullet point is under the category of nested deployments is actually kind of an implementation detail, so I'm not going to explain that here, but it's the idea of nested deployments is what makes this possible in the same way that it makes these possible. So once again, we've got a def host for the laptop. It's still running Bullseye. And then we apply this property which says dump an image here that evaluates this Lisp form. Okay? And once again, Consfigurator will keep that image up to date as we change the code in myCool executable. So myCool executable is this thing. So this is an extremely simple Lisp function. It's defen, right? So this is core Common Lisp now. This is not any fancy Consfigurator stuff. In fact, this is very similar to Emacs Lisp for people who have used that. And this function is very simple. It takes some arguments and it prints them out, one per line. And so when we deploy this version of Mate, then what we'll get is an executable that runs this. So let's do that. So deploy once again, sudo startup Lisp Mate, okay, and set that off. Sorry, I got the syntax wrong. You don't need those. It's like this. So let me try that again. So I turned up the debug output here, so you get all this as well, and it goes ahead and dumps it. And so if we run that now, user local bin, myCool executable file 56, and it tells us the command line arguments we passed, right? Why is this cool? Well, like often, like what we might want to do is have this executable run from cron, so we can use a property to have that done. And often, if you need something run periodically from cron, what you'll do is you'll write like a shell script or a Perl script or something like that. And shell scripts in particular are not much fun to write. They can be pretty fragile. And they can't pull information out of your config, right? So your definitions of hosts wouldn't be available. But if you just write a Lisp function and then dump an image to execute that function, then you can do anything here, right? Here we can import any Common Lisp library, we can refer to any of the def hosts established in our config, we can extract whatever information we need, and do whatever we want in a real programming language rather than shell script. Let me conclude by saying a few things about Consfigurator and Debian. So, Propeller and Consfigurator, I think, are both attempts to incorporate contemporary ideas about reproducible, programmable infrastructure into Debian-style systems administration, right? So, unlike something like NixOS or Geeks, which completely does away with the traditional ways of doing things and starts from scratch, and therefore achieves programmability and reproducibility, Propeller and Consfigurator are attempts to get the same advantages, or as many of them as we can manage, without giving up all the existing extremely useful packages that we have in the Debian archive. And I think that you can do pretty well. So you can get a lot of the benefits of Nix and Geeks without giving up on the maturity of the Debian archive and the advantages of the ways that we do things, such as the way we do security support. So these, like the demos here, these host definitions and property definitions are quite like what you write in your Nix and Geeks configuration, and they work in similar ways, but they configure Debian hosts, and we don't have to give up on all the advantages of that. And in particular, I think that Consfigurator's flexibility in applying small numbers of properties rather than always doing a full build, and the flexibility that you get from switching and chaining connection types makes it really efficient for performing these system administration tasks. It gets you the advantages of declarative configuration management, but also gives you, like, you know, something that respects the fact that systems are full of state, and that's what the REPL gets you. All right, okay, thanks very much. Thanks for listening to my presentation.
Right, well, thank you. And if you give me a second, we'll go to the live Q&A.
Hello.
Hello, hello. Cool. There we go. It's all set up. Are there any questions on what Sean has been talking about?
Yeah, thank you for the great talk. A question is whether the usual, I think I could call it usual features of more mainstream configuration management systems like Ansible and whatnot, like testing operations without actually executing them, are present in Consfigurator, or do you plan to implement it if not feasible at all?
There isn't a way of stubbing out operations such they don't actually do anything yet, but you could easily do that for POSIX properties because they have this very limited I/O. You could easily substitute that for something fake. That wouldn't be so easy for Lisp properties because the whole point is that you can just run anything. But what I'd suggest could be done instead is if you use this support for applying stuff to random containers instead of to real machines, you could use that as a way of testing your Lisp properties. So doesn't exist, definitely implementable would be my basic answer.
Cool. Are there any other questions?
Yeah, I've got another one. Do you know, by chance, that Propeller, why does not implement this POSIX approach?
So Propeller is, like aesthetically, it's one of these very minimal pieces of software. So Joey doesn't have any need to use anything like POSIX properties. He thinks that it's enough, if you can't run Haskell on the host, to just build a disk image of it. But that doesn't offer any means of doing things like that TC cron job on a random shell account, right? And I think basically it's just that Joey doesn't have any need for that, so he didn't want to complicate his project. But I mean, just exploring these connection chains has turned up all these useful possibilities. So I think it's a nice extension.
Cool. Any final questions? Are there any questions on IRC? If anyone's been keeping an eye on that. Okay, well, thank you very much, Sean, and thanks for
Thank you very much for coming.
attending the talk, and we'll see you for the next one.